In the previous videos, we have seen the relationship between Pascal's triangle and binomial coefficients. And from that relationship, we can be able to produce a general expansion for a plus b to power n. And a plus b to power n can be given as follows. N0 a to power n b to power 0 plus n1 a to power n minus 1 b1 and so on and so forth. Now what you can notice here is that the powers of a are descending and the powers of b are ascending from 0 to n. Okay, and the powers of a are descending from a to power n to a to power 0. Now we can identify the terms in this expansion, specific terms, and try to come up with a pattern for the general term in the expansion of a plus b to power n. So the first term is a sub 1 or u1 will be equal to n0, which we have here, a to power n b to power 0. The second term, u sub 2, will be equal to n1 a to power n minus 1 b to power 1. The third term is a sub 3, which is n2 a to power n minus 2 b to power 2. And the rth term, so u sub r, will be equal to n. Now you can see that whatever comes below n is 1 less than u sub whatever that is, right? So u sub r will be r minus 1. Okay, if you notice here the patterns, 2 and 3, right? 2 and 1, 1 and 0. So r minus 1, if that makes sense. And then of course the power of a will be a minus r minus 1. Okay, a to power n minus r minus 1. So that will be a to power n minus r minus 1. And then b to the power of r minus 1. That's the pattern, okay? That's a pattern from the previous terms, which means the r plus 1th term, so u sub r plus 1 will be equal to, now here what you're going to have is, we know that if you have r minus 1 and you plug in place of r, you plug r plus 1, this will simplify to r. Okay, so what I'm trying to say here is that if you plug r plus 1 in place of r, what you're going to end up with is nr, okay, and also n minus r plus 1 minus 1, that will be equal to n minus r, because you're replacing r plus 1 with r. Okay, replacing r plus 1 with r from the previous term. So the r plus 1, so you have n minus r plus 1 minus 1, which will be equal to, the ones and the ones cancel, so n minus r. That's what I mean. Okay, and then this will be b to power, again if you replace r plus 1 in place of r, that will be b to power r. Now so basically what we have here is what we call the general term. Okay, this one here is what's called the general term formula. So the general term formula can actually help us to get any term in the expansion of a plus b to power n. Okay, so the r plus 1th term is what we call the general term formula, and it can be used to find any term in the expansion of a plus b to power n. Now, there's some key points that I want to talk about on how to use the general term formula. Now, to find the third term, r is 2. Okay? Now, if you're trying to find the third term, r will be equal to 2. For example, here, the third term, all right, u sub 3, r will be equal to 2, right here. So that's the third term. Also, to find the fourth term, r is 3. So to find a specific term in any binomial expansion, the general term must be used. And I'll show you in the next examples how to use the general term formula. Okay, so in example 1, find the coefficient of x to power 5, y to power 3 in the expansion of x plus y to power 8. So use the binomial expansion formula. Now this formula is in your formula booklet. It basically states that a plus b to power n is equals to whatever comes first plus the general term, which is nr, a to power n minus r, br, plus whatever comes next. And it's similar to this formula that we have here, all right? This formula here that we started with. This formula is the binomial expansion formula. So basically, back to our question, we need to identify what n is, a and b, and of course, find what r is. So in our question, we can see that a is equals to x, b is equal to y, and n is equals to 8, which means the general term, so the general term is 8r, just substituting those, x to power 8 minus r, y to power r. Okay, and then we are trying to find the coefficient of x to power 5, y to power 3. So the required power of y is 3. Okay, the required power of y is 3. So by inspection, r is actually equal to 3. Okay, so we can see that the required power of y is 3. So by inspection, r is equals to 3. So we can plug 3 into the general term, and what we'll have is 8, 3, x to power 8 minus 3, y to power 3, which will simplify to, now, you can find 8 choose 3 from your calculator. So if you use your calculator, just go on to plug in 8 and then go to math, and then last column, scroll down to number 3 and then choose 3. So your answer will be 56. Okay, so 8 choose 3 is 56. So That will be 56 multiplied by x to the power 5 multiplied by y to the power 3, and which will be equal to 56 x to the power 5 y to the power 3. So we can finalize and say that, well, so the coefficient is 56. Okay,